Hello everyone. So today we are to go over the AP Chemistry 2021 free response question number 4. This question is about thermochemistry. A student investigates a reaction using hand warmers represented below. Here is hand warmer on my here in this. We have hand warmer right there. In this hand warmer we have this. Inside, we are interested in what is inside. That is iron. That iron is oxidizing in time. So in the air, we have oxygen. The air is composed of nitrogen and oxygen. Nitrogen is inert, oxygen is reactive. So iron is reacting with oxygen and transforming into iron 3 oxide. This reaction is highly exothermic reaction. As you see here, the delta HA, this one is not delta Ka. Let me correct this one. This is delta H. It is delta H. The chemical reaction is highly exothermic reaction. Per mole of the reactions, per 4 moles of iron, 3 moles of oxygen reacting, it is producing 1,650 kilojoules of energy. Now, the student mixes iron with a catalyst and sand in a small open container. The student measures the temperature of the mixture as the reaction proceeds. The data are given in the following table. Initially, before the reaction starts, the temperature was 22 degrees C. As the reaction started, and per minute, the data points are first minute, second, third, fourth, and fifth minute. Temperature mixture went up steadily, 25, 34, 37, 39. And in 50 minutes, it is slightly decreasing, 39.4 degrees C. And in this kind of thermochemistry experiment, we are always measuring the maximum temperature. Because this is open container, it is inevitable to lose some heat to the air. So we wanted to see the maximum temperature at 4th minute, 39.7 degrees C. And we are interested in how much the temperature was increased. So the final temperature minus initial temperature, that is called temperature difference, delta T. It is 39.7 minus 22.0, 17.7 degrees C increased. Let's see the problem. The mixture, which is iron, solid iron, catalyst, and sand, has a total mass of 15.0 grams and a specific heat capacity of 0.72 joules per gram Celsius. It means we have 1 gram of the mixture. To raise the temperature by 1 degree C, it requires 0.72 joules of heat. Calculate the amount of heat absorbed by the mixture from 0 minutes to 4 minutes. Now let's remember about the heat equation. So the heat equation, this is the heat equation. Amount of heat, Q, is equal to mass. M is mass, and C is specific heat, and delta T, temperature difference. This is the equation, and we need to remember this equation. Q equals MC delta T is often used to calculate the amount of heat. So 15 grams of the mass, 0.72 joules per gram Celsius, and temperature increased by 17.7 degrees C. Remember here, when I give exam to the students like this type of problem, students have struggling. They just simply see the absolute temperature, the temperature, Celsius temperature at 4th minute. They wanted to use 39, that temperature. No, delta T is the temperature difference. It is final temperature minus initial temperature. We are interested in how many temperature was changed. during this time of observation. So 17.7 degrees C, then grams divided by grams canceling out, Celsius canceling out. The remaining unit is joules. So let me put this one into the calculator. When I calculate it, I find the value 191 joules. Now let's think about sig fix 15.03, 0.722, 17.73. So this one is 3 sig fix. This one is 2 sig fix. This one is 3 sig fix. So finally, I need to represent the answer with 3 sig fix. So first is 1, second is 9. From the third one, I need to drop it. This one is less than 5. And remember, this number is the bigger than the decimal point. Then it is 190. Do not write it 19. Some students may make a mistake. Write this one, simply drop 1 away. The answer is 19. No, the value is, the number is less than the decimal point, then we drop it. But when the number is above the decimal point, we need to write 0 there. So 190 joules of energy, that much energy is absorbed by the mixture, meaning that the same amount of heat is lost, generated and lost from the system, which is the chemical reaction itself. Okay, once you know this one, then we can calculate the related quantities. Calculate the mass of ion in grams that reacted to generate the amount of heat, calculated in part A. Okay, so now let's see our system, which is the chemical reaction of this oxidation. Oxidation reduction reactions, which is iron is oxidizing C, this one is oxidizing, this is oxidation, and oxygen is reduction. So this is oxidation reduction reaction. Delta H is negative, so it is highly exothermic. So this one is negative, meaning exothermic. 1,650 kilojoules per mole of reaction. So we are given, like, this one is giving the relationship between kilojoules of energy, heat, and mole of the reaction. So we calculate 190 joules. So we have amount of energy. Let's convert this one to kilojoules of heat. And finally, we need to convert this one to the gram quantity of iron. And in this case, as before, always we have an intermediate unit. We cannot go directly from kilojoules of heat to grams of iron. We need to have an intermediate unit. And like, remember that mole number is almost always the intermediate unit. Now let's see how to convert kilojoules of energy to mole number of iron. So when you look at it, 4 moles of iron required to make the reaction going. Okay, so 1,650 kilojoules energy is produced per consumption of 4 moles of iron and 3 moles of oxygen. That's the meaning of this molar reaction. When I was studying these thermochemistry equations, I was confused how to interpret the mole number. It is 4 moles, but it is per mole. Isn't it per mole? No, this is per mole of reaction, meaning that per 4 moles of iron and 3 moles of oxygen. That's the meaning of this mole of reaction. Okay. And then second one is the molar mass of iron, 55.85 grams per mole. All right. So then we just calculated the amount of heat. 190 joules of energy is produced and absorbed by the mixture. So 190 joules, let's convert this one to kilojoules. Divide by 1,000, we have 0.19 kilojoules. Now let's get started with 0.19 kilojoules times 4 moles of iron required to produce 1,650 kilojoules of energy, and finally molar mass of the iron. Then here kilojoules cancels out, mole of iron cancels out, we are left with grams of iron. So then unit is grams of iron. Let's calculate it, 0.19 4 over 1,650 times 55.85. When you plug in those values into the calculator, we see that the value is 0.0257 grams of iron. Now, this one has 2 sig fix. So we need to represent our answer with 2 sig fix. 0.0257 So 7, we need to round up. 0.026 grams of iron required to make the reaction going and producing that much of energy. Now let's move on to C. In a second experiment, the student uses twice the mass of iron as that calculated in part B, but the same mass of sand as in the first experiment. Would the maximum temperature reached in the second experiment be greater than, less than, or equal the maximum temperature in the first experiment? Justify your answer. Now, two properties can be considered. Heat is an extensive property, meaning that and also iron is a limiting reactant because the oxygen is in the air and we have much more than enough than the air. The oxygen is available in the air. So oxygen is the excessive amount, iron is the limiting reactant. So as we double the amount of the iron, then the reaction will be doubled and the heat generated by the reaction will be also doubled. And because the same mass of sand, then the surroundings, the sand is the surroundings stay the same, but amount of heat generated is doubled. So then the maximum temperature will be higher, approximately double the amount of the approximately not equal because we are only doubling the amount of the iron. So it will be definitely higher than the first experiment. So this question is asking the students about, do you understand about thermochemistry? Can you interpret the data, collected data, and can you plug in the proper amount values into the heat equation? And it's about also asking thermochemistry equations, conversions, and the extensive property of the heat. Thank you, everyone.